Jai Hind to all. My name is Manoj Kumar, Assistant Professor, Department of Computer Science and Engineering, Ajay Kumar Garg, Engineering College, Ghaziabad. Today, in this video lecture, we will learn about the basic concept of singly linked list. This is the content that I will cover in this video lecture. First, we will see the introduction of linked list. After that, linked list versus array. What are the advantages of linked list over array? And then what are the basic steps to create a node in singly linked list? After that, we will see some basic types of linked list. And after that, we will start the singly linked list and traverse operation on singly linked list and the search operation of singly linked list. Okay. So linked list, what is linked list? Actually, linked list is a dynamic data structure. In linked list, we can store the data items or value in form of nodes, and nodes are interconnected with each other. So linked list is a collection of data elements called the node. It means data value are stored in form of node, and linked list doesn't store the element in consecutive memory location. This is the main difference between the array and the linked list. Basically, in case of array is a collection of similar kind of data element which are stored in consecutive memory location. But suppose if in memory the space is not available in contiguous manner, it means space is available in non-contiguous manner, then how we can store? For that scenario, we can use the linked list. So in case of linked list, we can utilize the memory space more better as compared to the array. So linked list simple is a data structure which can be used to implement other data structure. This is the advantage of the linked list, that we can use linked list to implement the other data structure like queue. Queue can be implemented using linked list. Next, stack can be implemented using the linked list. So this is another advantage of the linked list. So linked list is a dynamic sequential data structure in which data elements or value are stored in form of nodes, and nodes are connected with each other. And it is not necessary that memory space should be in contiguous manner. If a memory space available in non-contiguous manner, then we can also utilize that memory space to store the data value with the help of the linked list. And linked list is also used to implement the other data structure. So this is some basic overview of the linked list. Next, this is an example of a linked list. Here, 7 values are stored. This is a node. And each node, this is basic example of a simple linked list, or we can say that the singly linked list. Here, every node has two parts. This field is known as the data field, and this field is known as the address field. So every node in a singly linked list or simple linked list contains two fields. First one is the data field, which is used to store the data value. Second one is the address field, which contains the address of the next node in the linked list. Okay. For example, here this is a particular node 1, and it contains the data value 1. And this node, this is the address field. Address field of this node contains the address of next node in the linked list. Similarly, this is node 2. It contains the value 2, and it will store the address of next node 3. In the same way, node 3 will contain the data value 3, and address field of node 3 contain the address of the node 4. In the same way. Okay, so this is the first node, and this one is the last node. Now see here carefully. Since this is the last node of the linked list, it means it is a simple linked list of 7 nodes. So after this, there is no node in the linked list. So address field of the last node in the linked list will contain the null, and null is represented either by the cross, either by the simple null, or we can also use the -1 value to represent the null. And again, here is a start pointer. Start is basically used to store the address of the first node. It means suppose we have to find from where or from which node the linked list is started. So we can simply check the value of start pointer. So this is a start. Sometimes it is also known as the head of the linked list. So head or start of the linked list basically contains the address of the first node of the linked list. Okay, so in a linked list, it is a collection of the node, and in simple linked list, node contains two fields, data field and address field. Address field is data field is used to store the data value. It may be the integer type, it may be the float type, it may be the character type. And a second field is known as the address field, or which is used to store the address of the next node in the linked list. And the address field of the last node of the linked list will contain null, because after this there is no node or further node in the linked list. And this is a start pointer or head pointer which contains the address of the first node of the linked list. It means it tell about from which node the linked list is started. Next one is the linked list versus array. How we can compare the linked list and array, or we can say that what are the advantage or disadvantage of linked list or array as compared to each other. So first point is that both linked list and array is a collection of data element, and they are stored in sequential manner. It means the linked list and array both are the example of linear data structure. But in case of array, the elements should be stored in consecutive memory location. Okay, and in case of linked list, this is not necessary. It means linked list provide the better utilizations of memory as compared to the array. Another difference between array and the linked list is that linked list does not allow random access of data. Node in linked list can be accessed only in sequential manner. Linked list basically nodes can be accessed in sequential manner. It means we cannot directly access to a particular node. Suppose if there is we have to access the data value of this node, then at first we have to traverse it the sequentially. We cannot randomly access the value of this node. Okay, so we have to traverse all the node till the required node. Then that is why it is a can be accessed in sequential manner. Another advantage of linked list over array is that we can add any number of element in the linked list. This is the main advantage of the linked list, because in case of array we have to define the size, we have to fix the size. That is why array basically represent the static implementation. It is a static type of data structure. But in case of linked list, there is no need to define the size. Okay, nodes can be added or removed dynamically. Next one is the how we create a particular node. What is the basic syntax to create a particular node? So to create a particular node, at first we have to define a structure. Struct keyword is used to define a struct. So this is the struct and structure name is node. So to implement the program of linked list, two concepts are very important. First one is the structure in C, and second one is the pointer in C. Okay, if we are implementing using C, then so first we define a structure name as node, and it, since in case of simple linked list it contains two field, data field, so integer data type, and this is the address field represented as the next, which contains the address of the next node in the linked list. Again, we declare a start pointer, and initially we start is initialize it from null if the linked list is empty. Now to create a node, we will use this syntax, struct node asterisk new node. Whenever we have to create a new node, then we will use this syntax. Once the node is created, then next important task is allocate the memory of newly created node. So in linked list, to allocate the memory to newly created node, we have to use the dynamic memory allocation function. For example, here we are using the malloc function. So this syntax is used to allocate the memory to this newly created node. After that, once the node is created, memory is allocated. Next, the next step is to initialize the data field value and the next address field value of the newly created node. So to initialize the data field, so new node arrow data, arrow is used because here we are using the structure with pointers. So to access this, we have to use the arrow. So new data arrow data equal to value. This value may be either we can initialize directly within the program, like new arrow data equal to 10, or we can enter at the runtime using the help of the scanf function we can use for that particular purpose. And initially the next field we have to initialize null. This next field will be updated as we when we add the next node in the linked list after this newly created nodes, but initially this. So these are the basic steps. These steps are common for all the type of linked list. First we have to define a structure of the node, then we have to create a start pointer, then we have to create a node, memory is allocated to the node, and after that initialize the data field and next field of the new node. So these are the four types of linked list: singly linked list, doubly linked list, circular doubly linked list. We will see later each in detail. In this video lecture, we will particularly see the linked list introduction and the searching and traversing operation on the linked list. Okay, so this is the example of singly linked list. As I discussed that by default, if I am saying the linked list, by default it is the singly linked list or simple linked list, in which a node contains particularly two fields. As I already discussed here, this is the head, start or head, which contain the address of the first node of the linked list. This is the last node, and the address field of the last node will contain the null. And this linked list contains 7 node, which store the integer type of data value. So next operation, first operation is the traversing operation. How we can traverse a singly linked list? So to traverse a singly linked list, we will follow this particular algorithm. So suppose this is a given linked list and we have to traverse it all node. It means we have to display the data field value of all the nodes of the given linked list. Then how we can do that? So for that particular purpose, at first we have to declare a pointer PTR and start initialize that pointer with start. It means first pointer. So PTR variable pointer will refer to this node and we will move PTR till the last node. This is the first node and now we have to traverse the linked list. So we have to move the linked list till the last node. So in step 1, at first we declare a pointer PTR and initialize it with start. It means initialize it with the first node. In second step, repeat step 3 and 4 while PTR not equal to null. PTR not equal to null means until and unless PTR represent a invalid node. It means whenever PTR will refer to this node, then after this when we apply this step PTR equal to PTR next, then PTR will represent to the null. So this is the condition is used. This condition basically reflect that we have traversed all the linked lists. It means first here PTR, so again step 3 PTR arrow data apply process means here we can use the printf function, like we can use printf %d and PTR arrow data. Okay, so initially PTR initialized with first node, so this step will execute PTR arrow data, then 1 will printed. Next step, set PTR equal to PTR arrow next. Now PTR will refer to the second node. Again this step we will check this condition PTR not equal to null. This condition is true. It means PTR not equal to null. So program control will go to step 3 and it will print the data value of this node, and after that PTR will move to the next node PTR. Again PTR not equal to null, so program control will go to the step 3. Again we will print the PTR arrow data, then value 3 will be printed, and again set PTR is equal to PTR next. Now PTR will refer to the this node 4, and again since PTR not equal to null, so program control will go to the step 4. Value of PTR arrow data will be printed 4, and again PTR equal to PTR next. So this process step 3 and step 4 will be continue until the PTR will refer to the last node. Let's see. Once the so 5, 6 and 7 will be printed. So once PTR refer to this node now, and this value will be printed, 7 will be printed. So after printing 7, when this step will execute, PTR equal to PTR arrow next. So when PTR is this and PTR next is null, so after this PTR become PTR equal to null. So now this condition is not satisfied. It means complete linked list is traversed. So in case of traversing a linked list, what we will do? We will simply declare a pointer, either name as the PTR or temp, and initialize it with the start with the first node. And now we have to move this PTR pointer until the complete linked list is traversed. And what is the condition here? PTR not equal to null. Once the PTR become null, it means all the nodes in the linked list has been traversed. After that, only after that PTR will contain the null, like I have explained in this example. So this is the algorithm that we can use to print the data elements of the linked list or to traverse a linked list. Next one is the searching the data value in a linked list. Linked list contains the node, and we have to check each node contains basically a data field data value, and we have to check whether a given data value is present in the linked list or not. So for that purpose, we will use this algorithm. Okay, suppose this is a linked list, and this linked list basically contain 1, 2, 3, 4, 5, 6, 7 node. Okay, now suppose we have to find that node which contains the data value 4 is present in this linked list or not. Okay, this is a given linked list, and we have to search the existence of 4, data value 4 in this linked list. Then how we can perform, what algorithm we can use? So this algorithm will be used for that purpose, to search the presence of a data value or presence of a particular node in the linked list. So at first we declare a pointer ptr and initialize it with start. It means here start is a pointer and that start will refer to the first node of the linked list. So initially ptr is initialized with the first node. After that, repeat step 3 and step 3 while ptr not equal to null. It means until the ptr represent to a valid node, refer to a valid node, then we will step 3 will be executed. So since ptr is a valid node, it is initialized with the first node, so program control will go to the step 3. So here if val, this is a variable value which is used to compare the enter the value, or it means val, if we are going here to find the present of 4, so val will refer to the 4. If val equal to ptr arrow data, then set pos equal to ptr here. So value of this, when the ptr refer to the first node, so value of ptr arrow data is 1. So 1 is not equal to 4. Okay, so this step will not execute, then else step will execute. ptr equal to ptr next. Now ptr will move to the second node of the linked list. Again we will check this condition, val equal to ptr data. So ptr data is 7 and value of val variable is 4. So 4 not equal to 7. So these two steps will not execute. Program control will go to the else part and will execute ptr equal to ptr next. So next ptr will move to the next node. Again this step will execute. We will check this condition. So value of val variable is 4 and value of ptr arrow data is 3. So 3 is not equal to 4. It means this step will not execute. Program control will go to the else part and will execute this particular step. So when program control will execute this particular step, then ptr equal to ptr next. It means ptr will refer to the next node. It means ptr will move to the next node. Okay. So at this position, here in the at this position, again this condition will be checked. Now see. So val equal to ptr arrow data. Here we will compare equal operator will be used here. Okay. So val equal ptr arrow data. So value of val variable is 4 and here ptr arrow data value is also 4. It means now this condition is satisfied. Val equal ptr data, because what is the value of val variable is 4 and currently ptr refer to the this node and data field value of this node is also 4. It means the comparison is successful and 4 is present. So program control will go to this step. Set pos, this is a variable which is used to represent the position equal to ptr. Yeah, it means we have to print the index or we have to print the position. It means at which position the data value 4 is stored in linked list. So here 4 is stored 1, 2, 3, fourth node. So position value will be 4 and go to step 5. Okay, so when we will display the index of 4, so it will be presented by the 4. If suppose 4 will not present here, then linked list will be searched till the last node. Suppose we have to find the 10, existence of 10 in this linked list. Now, so 10 here comparison will not successful. Again ptr will move to this. Now 2 is not equal to 10. Again ptr will refer to the next node. 6 is not equal to 10. Again ptr will refer to the next node and ptr arrow data is equal to 5. 10 not equal to 5. And since the complete linked list is traversed and the match is not found, then we will set pos equal to null. So step 4 will execute only when the element or data value that we are going to search in linked list that is not present in the linked list. So step 4 will execute only in that case. So this is the algorithm that we can use to perform the searching operation in case of linked list. If element is present, then we will display the position of the node or node number. It means the given value is present at this position. If the value is not present, then we will simply display the message that the element to be found is not present, and we will set the position value in as null. Okay, so in this lecture we basically discuss two main operation. First one is on singly linked list. First one we have discussed the traverse operation. Second we have discussed the search operation. We can also perform the insert operation on the linked list, singly linked list. We can perform the deletion operation. We will see in the next video lecture. So overall, in this video lecture, first we have discussed the introduction of linked list, what is linked list. Then after that we have discussed the advantage of linked list over array, or we simply compare the linked list and array. Then we have seen the steps to create a particular node. Then after this these node we have discussed the types of linked list. These are 4 types of linked list, and in case of every type we can perform the insertion, deletion, creation, and the traversing and searching. This type of operation, common operation, can be performed on each type of particularly linked list. In this video lecture, our major focus on the singly linked list. So this is the basic structure of the singly linked list, and after that we have discussed the traverse operation, how we can traverse a singly linked list, and how we can find the existence of a given data element in singly linked list. Okay, thank you.